Okay, so welcome everybody to our CHIWORK weekly conversation. My name is Andrew Kuhn, and I'll be the host for Abdallah El Ali today. And before we get started, I would like to thank the technical program chairs who are hosting conversations this year: Navina Karusala, Toby Lee, and Solveig Shadan Segian, and Max Wilson. And I'd also like to thank our student volunteers. Alberta is here, and also Nabil, and Isabel Munoz is our web chair. And finally, I'd like to thank the National Science Foundation for partially funding this effort. So logistics, we will have about a 30-minute conversation with Abdel with some questions that I've prepared for him. And then within these 30 minutes, I'm also looking forward to your questions. So please put those into the chat, and I can call on you or I can read the questions if you prefer. And then after about 30 minutes, we will end the recording, and we'll have another 20, 30 minutes to have a more relaxed conversation without being recorded. So to get started, I would like to introduce our guest today. Abdallah El Ali is a research scientist at the Human-Computer Interaction at the National Center for Mathematics and Computer Science in Amsterdam. And he's within the Distributed and Interactive Systems group. He is also on the executive board of CHI Netherlands, which is an ACM SIGCHI chapter that connects, supports, and represents the ACI community in the Netherlands. He received his PhD in computer science and master's degree in cognitive science from the University of Amsterdam. And he is currently leading the research area on affective interactive systems, which we'll hear more about very soon. And he's focusing on ground truth label acquisition techniques on emotion understanding and recognition and affective augmentation systems that leverage physiological signals and multimodal feedback. So there's a lot of very exciting topics out there that you're covering. And what I wanted to start with to ask you is your work on affective systems, and specifically your work on what you call thermal wear, and you published this at CHI 2020. So thermal wear is about augmenting voice messages. And I first wanted to ask you about the motivation for this work, and this has to do with how people generate what's called emotional prosody, right? And so I just wanted to ask about that first.
All right. Well, first, thanks, Andrew, for the invitation to be hosted here on CHIWORK. So really appreciate it. And yeah, let's dig right in, maybe. So a bit of the work that I'm doing can be somewhat unusual in some respects. So the motivation is not always clear to us even as well when we start designing these systems. So sometimes we take a bit of a technology-centric perspective. But with thermal wear, so the idea is that some people have impairments in producing emotional prosody when they speak. So when I'm speaking, it's very clear. When you get an AI-generated voice, you feel something is a little bit off. And more than about generating prosody is also just perceiving emotional prosody. And this can be impaired. It could be situationally impaired. Let's say if the connection right now is not that great, during remote communication, we may be missing some cues, but also for certain disabilities or impairments. For example, an autism spectrum disorder, you have a wide spectrum, and some people could be impaired in perceiving certain emotional cues from voice. Also, one can think of, for example, if you have a voice assistant, you don't necessarily want it to have a human voice. This could be a way to augment the voice messages. But essentially, what thermal wear was doing is that it's exploratory work to see how thermal feedback and our sense of thermoception can influence our affective perceptions of the world. So essentially, it was an exploration, and this was a use case that we tried to kind of better understand.
So what does it do? What does thermal wear actually do?
What we tested, so basically the work was partly on fabricating this design. So it's kind of comfortable in a wearable thermal display that was on the chest. And what we did was we generated basically voice messages that were lacking in emotional prosody. And we had people wear this thermal display, and we either actuated cooling or heating effects. And some of those messages were positively valenced, and some of them were negatively valenced. And okay, aside from the comfort and rate of change that was on the technology itself, we started to apply thermostimulation, and we found some interesting findings. And we know from prior work that heating sensations generally are associated with pleasantness, social proximity, etc., while cold sensations can be unpleasant, can be cold, sarcastic, and this has been applied to different media, and it's usually been tested in isolation. So what we did here was we put it in the context of voice messages, and we found that, as in prior work, thermal stimulation does influence the valence of a voice message, of a neutrally spoken voice message. But this varies across cool and warm stimuli. So while the warm stimuli increased the valence of positive messages, this wasn't necessarily so for negative ones, not on the same level. On the other hand, the cool stimuli lowered the valence of both positive and negative messages. So think of it this way: if I say something and just say you miss the emotional prosody, and I give you a cooling sensation, then you start to think that this was sarcastic somehow, even though it was a positive message. But somehow the cooling changed your perception of, are they really being sincere or not? And of course, you can think of, like, let's say let's say outside, it's very cold, it's not the right conditions. It influences us. So we try to understand a little bit to what extent this influences us. And in a way, it's a bit scary, and maybe I can talk about that later, that even our affective perceptions can not necessarily be taken for granted because of certain stimulations that we can apply. And I'm talking outside of clinical settings. In clinical settings, maybe this is the point, really. So that kind of what the work was pointing to.
That's really interesting. And let me just quickly follow up. So what sort of temperature changes did you apply? So what was cold? What was warm?
So the skin temperature sits around 37 degrees Celsius. And then we would apply, let's say, up to, 40 degrees. That's what's, so a few points temperature differences. And similarly with cooling, we would lower the temperature. And then we did some explorations as well on, the comfort that you have with respect to this and how fast the change happens. So when you're working with these Peltier elements, it's a little bit tricky and a bit frustrating as well to get the rate of change correct. And if it's not, then you don't know anymore. And with voice messages, it was especially tricky because they're short in duration. So you want the heating or the cooling to coincide with the onset of the voice message. So it needed to be fast. So that was one of the challenges that we had in preparing this work.
That's very interesting. So related to this, so you're interested in augmenting affective information, but you've also done extensive work on understanding how to estimate emotions. And so, not surprisingly, your one of the arguments you make is that you really need good ground truth data, right? So you need to understand what people are actually feeling when you measure certain things. So can you tell us more about that particular work, the ground truth work?
Sure. Yeah. So there's a different strands of research that I'm following. So what we discussed was more on what we're calling effective augmentation systems. But indeed, a related area is on trying to understand emotion and recognize emotion, whether that's even possible computationally or not. And so this kind of strand of work started with a frustration with a lot of the affective computing research that's been done, where basically you're training machine learning models by getting a label, getting somebody to watch a video, let's say, and it could be a relatively boring video with maybe 2 seconds of very interesting content, which excites you. And then people were being asked after the video ended, how positive was the video and how excited did you feel? Now, this feels strange, right? We're making predictions based on what somebody told you about some memory recall of a video they just watched. So we're like, okay, no, this is not really, if we were going to be asking for self-reports, then let's just try to ask people as they're experiencing the event or situation. So we started to argue for what we called momentary annotations. And so real time and continuous. So it had to be happening right now. So what am I feeling right now? And it has to be happening over time. And of course, you think that this is cumbersome, right? Why? How can we do that? So we tried to develop some techniques which made it very easy. So leveraging some HCI principles to make it easier for people to watch a video and at the same time effortlessly in a different quadrants of this valence arousal space that's commonly used in effective computing to indicate, oh, this is exciting, this is not exciting. And we did this for mobile devices. And then we found, like, for example, some established data sets, some of the sad videos were not that sad. So they were being labeled as sad by participants who watch a video and label it after the fact. But if you really look at the temporal aspects of the video itself, the picture starts to change. We followed up with this work on trying to apply the same techniques in 360-degree videos in virtual reality. But there we have a problem, right? Because if I'm wearing a headset and I'm seeing a 360-degree video and I have a certain navigation pattern and you do the same, and let's say Shadan does the same, how do I guarantee that my labels will correspond to the same frames as you? We're all looking at different parts of the video. Of course, there's some works on, viewport prediction to try to see, I'm more likely to focus on the cat that's happening on my right viewport than not. So with that work, we also try to come up with techniques to sort of merge the viewport, so that we know that those labels that I'm now labeling correspond to that specific set of frames. And then we did some experiments, of course, with the recognition. But I'm not a big fan of this emotion recognition aspect because it's very constrained. It works in, let's say, a video-based scenario, but for people to claim that we're recognizing your emotion, no, we're recognizing your self-report to some extent. Yeah, so that's
Got it.
basic.
Yeah, that's interesting. So I wanted to focus a bit now on this conversation on this general topic of our conversation series, which is HCI and work and HCI and worker well-being. So how do you think that the work that you've been describing, right, on affective augmentation and emotion ground truth, which perhaps you don't quite believe in, but still, right? So how do you see the connection to supporting, HCI supporting work and HCI supporting worker well-being?
Yeah. So again, maybe I'm synthesizing here. So I'm trying to see how the mapping works. So maybe it first helps to define what do we mean by effective augmentations. So at least the way that I'm using it, it's that there's advancements in biosensing, quite a lot. There's also advancement in actuation, and these enable us to visualize and share our hidden physiological data. So I can share my heart rate with you. I can share my breathing rate with you now, thanks to a whole set of techniques that are available to us. They also allow us to create artificial haptic sensations, for example, using either thermal displays, vibrotactile displays, and we can distinguish between recreating a sensation and representing some sensation, right? So I'm not trying to, let's say, some strand of work trying to recreate social touch. How does it feel that a human touches you on the shoulder? But you can also have a representational view where you just say, this could be an indicator that something has happened, either a notification or whatnot. So, and these kinds of technologies, at least from a human augmentation perspective, they could be assistive, empowering, enabling, augmenting, but it's not clear how this works on the affective level. And I want to say affect here and not emotion because, again, we don't really know. Emotions could be a very subjective, very private thing. With our affective states, with our physiological signals, there could be manipulations at a physiological level. If I give you a faster heartbeat, we know from prior work that people start to synchronize with that. If you go to a nightclub and the music's fast, of course, not necessarily, right? But our physiological signals and our movement, our behaviors, we could start to synchronize with these things. So how does this relate to let's say, the future of work, to hybrid experiences? So one area which I find very interesting is basically to have a more of a kind of inclusive hybrid experience. And the reason behind this is, if you've been in a hybrid meeting, and I guess many of us here have, what typically happens is there's some people that are co-located physically, there's others that are virtually there. And what often tends to happen is, at least from my experiences, is that let's say we have a meeting, we want to have a discussion, we have some questions. We're like, okay, let's give the floor to the virtual participants first. Please ask your questions. And they do. So we're all looking at a screen. And then after let's say the virtual participant is done, what typically happens afterward is that the physical participants start to interact with one another. And what pretty much always happens is people start to forget about the virtual participants. And that's quite frustrating. So what we want to do with this is to kind of enhance this sense of social presence, to be able to make people aware of the others at an equal footing, so that if I'm physically located or I'm virtually located, it shouldn't really matter. So in that sense, we would like to apply these affective augmentations to be able to maintain a sense of emotional connection or affective connection between one another in such spaces. And it's, of course, also used as a kind of a social emotion self-regulation tool, right? If you see somebody, struggling, you could also regulate yourself and them by looking at each other's, let's say, physiological data. So this is kind of the strand of work we're trying to do. So from trying to recreate physical affordances and affective social cues in one manner or another, by leveraging sometimes strange approaches of, let's say, using physiological data as a resource to designing new experiences, which are maybe largely unfamiliar to us right now.
And so actually, you're one of the organizers of the SensiBlend workshop, right? Which kind of focuses on this blended experience of in-person and online participation in, let's say, a workshop. So with what you were just talking about and with your experiences from SensiBlend and that group. So let's say you and I have this conversation in 10 years again at CHIWORK 2033. And what should it look like? What do you think, if you can look into the future and take some guesses, what do you think is going to happen?
Yeah, thank you for this question. It's very difficult to know, really. But okay, so at least my say sort of vision of computing is that we're already highly interconnected. We have devices that are either wearable or integrated in our bodies. We're going to be part of this. And one of the issues that I see is, as the future comes to us, our realities will become much more personalized to a large extent. So what I experience on a day-to-day basis is going to be largely different than many others, unless we form some shared circles. And with SensiBlend, what we were trying to do in that workshop was to try to leverage sensor technologies of behavior tracking, emotion tracking, and whatnot, to see how we could make these hybrid experiences better. So now let's suppose we are 10 years down the line. So one thing to me seems clear is that the ancient ritual of gathering together is not going to go away, right? This is something that we prize as humans, or I feel that we prize as humans. But then again, what's the purpose of this, right? If you want to, like, I would say that our AR would be, for example, a useful vision of computing by then for people that say you know well, where you want to interact in the world. But for entirely virtual meetings where, let's say, there's several people, which I don't know, like, for example, in this call, there's many unfamiliar names to me, then I'm very happy to go into a totally virtual space and connect with one another. Now, the thing is, our capabilities for, let's say, creation of avatars for yourself, for myself, and also my ability to customize, let's say, all your avatars, if I so wish, this will become very easy for us. We're already seeing this a lot with generative models these days. You could spawn up a brand new avatar with a simple prompt, and we could take on that person or creature or whatever it is. So one of the challenges I see is this kind of seamless switching between avatars, personas, and devices. And I think that will get very, very easy. So in that sense, if we are running this still 10 years down the line, we may eventually, let's say, come up with some ground rules saying, like, for this kind of meeting, we would request everybody to take this specific avatar type so that communication becomes easier. And for example, here, we don't need to necessarily physically interact, right? I don't need to give you a coffee cup or cheers with you because it's in the work session, let's say. But this will vary on what type of work activity it is. So in that sense, I think many things will stay with us throughout history. In the past, so long as it's been happening this way, it will probably continue to happen that way. But there will be, significant change with this ultra personalization and avatar switching, let's say. So again, very speculative. I am to be nonsense, but that's kind of where my thinking is going these days.
No, I really like the point about the long history of in-person meetings that are unlikely to go away just because, right? And then how you think about how to extend that. That's really neat. Thank you. So I want to make sure we have enough time for questions from all of you. So please do feel free to either type or just raise your hand, and we can continue the discussion that way. And as this is happening, I don't quite see a hand raised, but if I'm missing something, please tell me. Oh yes, I do see a hand raised. So Shidan, please go ahead.
Yeah, thanks first of all. And I had one question regarding the first topic, the thermal cues. So in natural, what we call natural human interaction with the environment, normally you have this, so basically your emotional or affective state is a reflection to the thermal stimuli from outside. So for example, you feel some heat and so on, and so you get angry and then your body gets warm, and then you get stressed and your body gets warm, and then and sometimes also like you have fear and then you feel cold, and then it's also mixed because sometimes you're happy and you feel warm, which is a positive in comparison to, for example, anger, which is a negative state. And but you're using this the other way around. You're giving the cues, like thermal cues, as a stimuli, and then you're using to actually evaluate what is the affective emotional state. And how does this mapping happen? So because it's completely the other way around, and I was just wondering, how do you deduct that?
Thanks, Shadan, for this question. Okay, let me try to clarify. So with that study, what we're trying to do was to see, do the perceptions of the voice messages change? And do they change as a function of what stimulation you apply to me? So we've seen from prior work that, let's say you have an image and you're seeing a photograph, and let's say you give some kind of warmth feedback. Does that change, the valence of the photograph? Does it feel more pleasant to you or not? Now, what you're talking about is super relevant, because suppose we get people to run on a treadmill, their body heat goes up. And then you do the same experiment, and then you're applying thermal stimuli on them and heating stimuli in specific. What's going to happen? They don't feel it. We have a study right now happening where we're looking at virtual avatars in social virtual reality, and we're playing on the idea of kind of haptic proxemics, so that if I get closer to the avatar, I would feel some body heat. That's the idea. And we want to see, do people get closer or not? So we're kind of trying to recreate some existing social theories on that. When we get closer to people, we feel more of their bodies. And then there's a certain distance we don't want to trespass because it's too personal. And we want to see the stimulation of the sort change the way we interact. Because suppose in the future, we are all wearing, VR headsets, and we want to, let's say, experience more from another person. Of course, it's a bit scary as well, but let's say this was the case. So we were trying to understand this. And what we've seen from our study is that, of course, some people naturally have a higher body heat, let's say. And for them, it's almost imperceptible. So we would need to, for example, customize it. But we also cannot give people more than 40 degrees Celsius stimulations because we don't want to burn them. And so in that sense, yes, our affective states influence our body temperature, but our body temperature artificially stimulated can also potentially influence our affective perceptions. And what's the mechanism behind this? I mean, this would then be in the area of affective neuroscience, which I don't feel an expert to talk about.
Can I just have a small one on top of that? So what I also was wondering is that I might understand warmth as for example, an indication of anger, and you might understand it as care. So how would, if I get a text message that could imply both meanings, how would you, how can you make sure, or how could you, test, or are we going through new paradigms of interaction that we define that when it's warm, it's angry?
No, that's a very good point. And I just want to be very clear that, this is not deterministic. I also sometimes doubt whether this type of specific study could easily be replicated, depending on who you test. We know that, let's say, older participants maybe have slightly lower body heat, and then maybe can feel something more. What is interesting is that we did see this change. And that's all we can say, is that this made an influence. And if such a thing can influence that voice message, then we may have an issue that if we are now suddenly artificially stimulating people with all this new technology, what would that do to our perceptions? So it's not because at the end of the day, I still feel that the human will decide in the end. We have a study running now where we were letting people watch news videos and also giving them vibrotactile and thermal stimulation. And this different, apart from all the ethical issues that come up with trying to do that, is that also many people just actively suppress it. They're like, I don't want to pay attention. I'm too immersed already in the video. And then whatever haptic stimulation you give maybe doesn't have an impact. And for others, it may have. But the fact that it does sometimes, and also relatedly, of course, we're testing, valence and arousal on this two-dimensional scale. That's which one can wonder whether, the richness of human experience can be summed up by a two-dimensional valence and arousal scale. So that's another aspect of this. So we didn't look at, say, kindness, care, all the nuances, and also partly because it is maybe perhaps too subjective to really explore.
See, thank you.
You're welcome.
It's a fascinating topic, and it's so I like the points that you're making about how complex and potential. Basically it's complex both in terms of the number of variables and then also the additional variable of the person, right, who's experiencing it.
Yeah.
This is really fascinating. Abdul, I think what we should do is slowly wrap up our recorded portion of the conversation, and then we can move over to the unrecorded portion. So before we stop, again, thank you very much for joining us today, Abdul. And next week, please join us for a conversation with Hai Zhu, who will be hosted by Toby Lee. And so we can stop the conversation, and please stick around for continuation without the recording.